So the humanities guys are back on stage. Thank you very much for giving us the opportunity to present your new scripting language, which actually isn't new at all. But for the next 30 minutes, we are happy to present you TXSTEP, which I just showed you yesterday in the demo jam, an open source toolbox for the e-humanities and I think beyond. So first, let me just introduce ourselves. So my name is Tobias Ott. I'm CEO of the Pagina Publishing Technologies in Tübingen and teaching for the last, I think, 18 years now at the Stuttgart Media University, the XML technologies. And next to me, this is my father, should be, after graduating in theology, was majoring in classics, and then he got acquainted to computing since 1966 because he was called to the University of Tübingen for supporting computer applications in the humanities, and that was just what we are talking also here today, because this resulted actually in the development of the so-called Tuebingen system of text processing programs, which is known as TXSTEP since 1978, I think. And he may be also, as I told you yesterday, known to some of you as one of the founders of the TEI in 1987. So this is us. And now what we're talking about today. First, I want to clarify, actually, what means scholarly text data processing. And please let me just start by making a little survey. Who of the audience has a background in philology or has ever come to contact great with the so-called e-humanities or digital humanities? So you're quite familiar with that, maybe. So what is scholarly text data processing about? Scholarly text data processing is just what the digital humanities or e-humanities do when working on texts. So more precisely, the technical aspects of their work, the computer-based analysis and processing of textual data. This may include, for example, the computerized analysis of the metrics of Latin hexameters, poetry, so like this here, for example, which actually was in the late 60s of the last century just the first program which TXSTEP actually started. So this verse here is just, this shows the desperation of the god Apollo, and my Latin is not very good, but it means something like, oh my God, oh poor me, and there is no herbs against love. But this is true, actually, I know. But if you want to spell or to pronounce this correctly, it's very important just to know the durations, so the long and the short of the hexameters. I couldn't do this, but there is machines who can do this for us. Actually, we will show you some very similar case afterwards. Okay. So what I already showed you yesterday as one of the very elementary functions needed is the comparison of different versions of a text. So the most advanced area of application for this is in an editorial project to collect the variant readings containing in the manuscripts or other sources which are used to reconstruct the original version of a text or to make visible the genesis and writing process of the text, or the history of its transmission and revisions over time. So just to give you an example, the Greek New Testament has been handed down to us in about 5,000 different Greek manuscripts. Not all of them are relevant, but the latest edition of the Greek New Testament is the so-called Nestle Aland, lists readings from 423 Greek and 67 Latin witnesses to be compared just to rebuild the original version of the Greek New Testament. So, as you see, in the humanities, you do not only want to compare texts to have a kind of change tracker, but you want to work on the differences as the first result of research. But also, apart from the humanities, we at Pagina in Tübingen, we use the comparison tool for many, many reasons. Actually, to optimize our process chain, for example, to compare the results of double keying when we're digitizing written sources, or you may also think of the following application case. If you got a Word file which an author, brought from an author, and you brought it with some effort and rework into a valid XML file, and afterwards you realize that the author just was correcting still on its Word file. So it's very helpful that you can compare the Word file to the XML file, and not only to see the differences, but also to get a correction file that can bring in the corrections automatically into the XML file. I hope we can make a presentation of this maybe next year. Okay, apart from comparing texts, there are lots of functions needed for a philologist who want to work systematically on text sources. So I won't reread it now. Scholarly text data processing is just the sum of the computer-based methods of working on historical sources and contemporary texts. You might want to reconstruct the original damaged version of a medieval text where maybe mice just nibbled on the left side of the document. So it's very helpful to have a reverse index of all the words of the manuscript. Maybe you discovered a new undated text document and want to put it in its right historical perspective or authorship by building up statistics about the vocabulary and grammatical constructions of an author, or the relative frequency of vocal elisions in Latin poetry. This is what we just will show you afterwards, just to wake you up, actually. So after all, what we're talking about, all the techniques and methods that you need when the text itself is just the subject of research. And this is what originally TwoStep, just beginning 40 years ago, was made for. So this is what we're talking about today. So let me just show you with one little sheet what TwoStep was about, what TwoStep is about. So it's called the Tübingen System of Text Processing Programs, and it's a toolbox. It's just a toolbox that does not provide prefabricated solutions, actually. As you might have imagined yesterday, this is not the fact, but just a set of configurable modules that do the job of very basic operations needed in the humanities. And the output of every module can be used as input for any other module. So TwoStep is a kind of pipelining language. So when comparing two texts, not only a list of the differences will be produced, we also want to receive a file which only contains the differences of the compared texts, for example, for automatic correction. So also correcting the correct module is one of the modules of TwoStep and TXSTEP. So whoever of you already might have used TwoStep will surely be happy about this approach, but might admit that the syntax that TwoStep had until now, which was perpetuated since the 70s, is a kind of rustic. So this is what TwoStep is a little about. In fact, many of the modules are rebuilt during the time. So just the compare module is some 2 or 3 years old, but the syntax just stayed the same. And this is why we're here, actually. So this ends now. and this ends here. So for the more or less the first time, we just want to present you TXSTEP. Yeah, the new unicorn, because it's just the same as two-step. So we didn't rebuild the modules, the processor itself, which is incredibly stable and performant, but just the interface. So there is right now a XML syntax, behind lies an XML schema, that represents all the parameters for all the modules that two-step supports, almost all the parameters. So it's a kind of prototype. And actually the idea for XSTEP was born right here in Prague some 5-6 years ago, when I myself heard the first time of languages like XProg and others that use XML as a programming language, and I just came home and said, this is just what we need to rebuild two-step to present it to a greater audience. So this is what we're talking about, and just now I talked enough about this. So just let us start beginning the demo. Not to switch around every time here from PowerPoint to TXSTEP and back, but just want to show you first the main parts on the slides, and then having time, I hope we have time enough, just demonstrate you some of the very most important functions. I really want to show you what happens at the Faust edition, the edition of Goethes Faust, which is one of the, I think, most important electronic editions of the days, and they just use TXSTEP already for comparing all the witnesses, and we just have their original scripting here, so we just can compare the whole Faust afterwards in some 1/10 of a second or something. Okay, so yeah, and afterwards we're just counting some syllables in Latin hexameters because we can do it. Okay, before showing the example of the Faust edition, let us just have a very short look at how TXSTEP works. So here, just on the root element, when you're clicking on the F2 key, you just see all the modules that there are, and you see compare, collate, correct, prepare, index, prepare, sort, and sort are two different modules. We will show you later when this is helpful. Generate, index, transform is what we don't need that much anymore, because this is just what XSLT does well, at least as well as we do. Insert, renumber. We'll show you some of these modules. Okay, so how does TXSTEP just work? So first, we define variables, giving short names to the files used in the script. So what you just see here, beginning in line 4, ending on line 10, we just have variables to have short names of the files, version A and version B, and afterwards to output files that are just these here, one used for the human readable list and one for a TEI tagged list that can be processed in a further process. Okay, so this is just now the compare element, just as an example. You see here, this is just like the demo jam yesterday. Beginning in line 12, we compare, and now just version A is the variable version A, so one file. This does not have to be actually an XML file, so we can use almost every kind of coded data and compare it to the version B. And please write the variants to the diff file. This is also a variant, of course, and the listings and etc., etc. And here is written I think we show you this later in the demonstration, just not to run out of time. And this is just the human readable list, which shows the differences, and what I couldn't show you yesterday because 5 minutes is even less than 30 minutes. We just make the comparison very precisely so we can address every single character, as you see here in the file. And you see a plus for inserted characters, the minus sign for omissions, the asterisk for replaced characters. And this list is very okay for eye inspection, and if you only have 2 versions of a text. And for all other cases, actually, we make use of the variants file, which is shown here. So this is the other output of the compare module. Getting a variance file started with the readings. Pardon? Okay, this is word by word comparison, not character. My father is also so precise. What is he's right in doing so. Okay, so I think we have a closer look to this also afterwards in the live demonstration, because it's. But I hope you see just what the comparison file looks like when there is the version in the A file and the B file, and what is, so here, for example, mode omit and mode insert and replace. So I think you just begin to know what we're, how TXSTEP works here. Okay, so just let me see. This is already the compare locations. Okay, so if for producing, okay, the list, yeah, right here we're just producing. Also, this we will make in the demonstration easier to be seen. We're producing a list for the automatic correction, which is really a very, very helpful tool. So what are we doing to make automatic correction? Actually, this is the same reading list again, which shows all the differences between version file A and version file B. And now here just starting and bringing a comment to some of the parts. We can, so this is the sheet that I was looking for. We can use the correct module, and the correct module just takes the variance file as an input, because it has a very, very precise location where the differences between the 2 files are. And now you can say, okay, so please use the variance file, or a corrected version of the variance file, of course, to bring in these corrections to the version A or the version B to have a automatic corrected version of your text, actually. So this we show afterwards. And so right now, I'm in the time, perfect. To the Faust edition as at the moment, I think, most important use of TXSTEP. The Faust edition, so the edition of the Goethes Faust, is about 4,500 pages of manuscripts that have to be compared and transformed and etc., etc. Here also I just go through these slides rather quickly because it's not so sexy just to show it on the slides. But what we can just show you here, that the first list we generate by comparing the files is, in this case, just 68 pages, shows that many of the differences are of minor importance since they concern orthography only. For example, the long German S, like here. So this is just another kind of writing, but it means just the same. So we compare, or they, the Faust guys, just compared the text again and ignore readings, which only show differences listed in, so here the normalize in line 72, there's the normalize module that just brings the text back to a normalized written version, not rewriting the text, but just for the comparing. And after this normalization, the list is reduced just to some 10 pages, which have really the relevant differences between the sources. And here they just showed us one. So for all the people who know German here in the room, which is really, as they told me, a very, very significant variance. So Name ist Schall und Rauch, and in another version there is written Natur ist Schall und Rauch, which means name is, so what the, okay, what means Schall und Rauch? What the hell is a name? Yeah, and the other nature. This is really a very, very significant difference between the sources. We will show you this after. Okay, the other one I showed you yesterday, I just go through this because we have already seen it. Maybe later on we can show you the 12 articles of the Farmer's Right, because we just there compared 12 versions. And at the second to last demonstration that we prepared is just here by an ancient Greek text, which is, as my father told me, the beginning of the Gospel of Luke. He said it is well known worldwide. Okay, might be. And what we want to do here is to prepare a reverse index. So every word just sorted from the back end. Where is this good for? What is this good for? For example, so this is a real task. If you have a manuscript that is really just damaged by mice or fire or something like that, to reconstruct the words, it's very helpful if you just have the last 2 or 3 characters of a word. Which could this be? What word could be meant? So it's really helpful just to have a reverse index. How this works, I think we can just show you some more minutes we have. I go through this a little bit. Yeah, you see here in the line 42, sort key, order, reverse, and then a lot of things happen, and you come to a index that is just sorted from the back end of every word as a list or then as a tagged file. Now this is not a TEI, but just a kind of tagging that we invented on ourselves, where right now not the frequency count is pulled in, but the references to the text where, from which the entries have been generated. Okay, the last demonstration, we won't pick up every demonstration, is just the Latin hexameter poem that we want to show you, where we want to count the syllables, not only counting the syllables in the Latin hexameters, but also see how many wait here. So where is it? On the next slide. Okay. Pardon? Okay. Yeah. Okay. So just going back. How is it called? Elysians? The Elysion? The elided. Okay. So when you have 2 vowels coming together from 2 words, so you just okay. Well, if it's like this. Okay, so I think this is just what we wanted to show you, or what we want to show you. So not the demonstration itself is the important thing, but just to see that, to make you see that there is a scripting language with you can make all this quite easily yourself. And now for the last 4 or 5 minutes, we just should at least, Mohammed, 3 minutes, 4.5 minutes.
2, also 2 Minuten plus.
Yeah. Okay, so I just, so I just switch to the Faust example that is here. And first we run it, and then you see just the example. So this is not more impressive than it was yesterday, actually, but but it's just to see. Now this time it's 4,000 pages, is a little bit more than the very small examples that we had yesterday. Okay, but just maybe to show you, well, what? Okay. So we just take another project. Is the analysis? Or what? Okay. Or the reverse index? Na, lass mal das jetzt schön durchlaufen. Okay. So this is the syllable counting script. So just to show you how this is made, defining string groups. I know we have too less time to do that. So just let it run, and you see here this is the average first counts 15.24 syllables, and so yeah. We just stop here because else I do not want to get told by Mohammed that I'm running out of time. So no, I think okay, basta.
Thank you very much. So we take 1 minute for questions or comments from the crowd.
For Latin prose, it would be nice if you could add a dictionary with quantity information in it, so that you can analyze prose and its rhythm. Can it be done?
So what kind of analysis do you think of
well,
now?
Latin has long and short vowels, and if you have Latin prose, this is important. So you're using the first, and you know its patterns because it's hexameter, but you would do the same analysis for prose to see, for instance, what Cicero is doing with long and short vowels, and you need a dictionary for that.
Well, it's easier, of course, to do it for poetry, because you have the schema of the metrics. But the whole thing is, well, in this case, the length and the shorts of the syllables is not contained in this script, but it had been done earlier. This was another project, and we had not, in the source of this demo here, has just, for every verse, had just the metrical schema. Here we counted only syllables, and we counted, we counted the elided syllables by looking for the difference required by the schema and the syllables actually found in this case. But the metrical schema of a prose poetry, there are rules for Latin. For example, vocalis ante vocalem corripitur. That is, a vowel before another one is always short, or a vowel before two consonants, except and so on, is always long. And with those rules, you get very far.
But there are words that you have to know. For instance, anus and anus.
Yeah, of course. That's not, well, also for poetry, I arrived only at about 96% correct analysis without intervention. 3% with 2 or 3 possibilities and 1% with a false analysis. And you cannot rely for everything on automatic, but you have the material and you can, as a scholar, you can correct it and you can intervene at the appropriate places.
Okay, thank you.
Da war noch eine Frage.
Jim Fuller.
Sorry.
The first one was here, but you did not see him.
Fascinating stuff. What's the technical architecture underneath this? When you're hitting oxygen's transform button, what have you implemented this in?
Well, the basis or the processor behind TXSTEP is TwoStep. And TwoStep has been built from, well, in fact, since '66 of last century. First, the elementary function is in assembler, later in C, and the larger framework is always Fortran. But the principle behind is, well, antiquated. Fortran does not exist since 1970, more or less, they said. In fact, look for the sciences departments, everything is doing Fortran still. But the basic concept is that we do not, we did want to provide elementary functions of text processing, for example, prepare for sorting. You first isolate the elements which you want to sort, then you prefix them with a sort key. It's a transformation of the element you selected, which allows then to apply a standard routine for sorting, and then a further step just saying how to make from the sorted material, how to build the actual index entry. And this, the parameters which are specific to a project can be given by the user and must be given by a user. For example, as a standard, we require from the user that he actually defines the sorting sequence for a foreign language. For example, for Greek, first alpha, then beta, then gamma, which is in Latin only the 5th character, in Greek it's the 3rd character, and so on. And so he can define in every detail what it needs, but does not need real programming. That was the concept behind it.
Okay, thank you. Thank you very much. Thank you very much.